right 1, 2, 3. So my slope is just up 3, right 3, which just ends up being 1. So when I talk about my slant asymptote, it's just going to be y equals 1x, which you can write the 1, you don't have to, minus 2. So now I have my slant asymptote. Next thing I would do if I was doing this kind of in real time with an equation is I would look for any holes in the graph. So if I look at this graph, I do see that there is a hole, and I write the ordered pair for that coordinate. So what is exactly the point that's missing? And in this case, it looks like it's the point 4, 0. Now we have to think about x-intercepts. So x-intercepts, we can't count the hole as an x-intercept, even though it's on the x-axis, because it doesn't exist. The hole is a point that's not actually there. So the only other x-intercept we have would be right here. And that's when I zoomed in, I kind of saw that it intersected the x-axis there. And that would be the point, looks like negative 1, 0. So I've got my x-intercept. I've got holes. Next up will be vertical asymptotes. And those are typically just, x equals some number. So we have 2 of them. We have one here, and we have one here. And those go through the points x equals negative 3 and x equals, is that positive 3, I think? All right, so this is the stuff you just kind of observe from the graph, and you're just sort of writing down your observations. That's what all of those first few things are. But then you get to your domain and your end behavior, and you have to think a little more critically. So we'll do domain first. And what's interesting about domain is that it is directly related to any holes in the function and any vertical asymptotes in the function. Okay, so there's 2 ways that you can actually write the domain. And the first is to just use those 2 pieces of information, and that's going to be your excluded values. The other, when you're first starting to kind of do this with these complicated looking functions, would be to I take my pencil or pen, and I start at the leftmost portion of the graph. So as far left as I can go, and I begin to trace that function. Okay, so here I am, I'm tracing along the function, and I keep going until I have to pick up my pencil. So because right here, in order to stay on the graph, I'm going to have to pick up my pencil and go up here. That's a break in our domain. So what I know is that everything from negative infinity until I get to negative 3 is good. It all is part of my graph. So that's how I start my domain, is from negative infinity to negative 3. That's the first portion of my domain. And what that says is that everything up to but not including negative 3 will be on our graph. Now I pick up my pencil, and this is the next portion I'm going to trace. And again, when I start tracing this, I keep going until I have to pick up my pencil again. So to keep tracing along this graph, I'd have to pick up my pencil and put it down here. Well, I'm picking up my pencil and going around the x value of 3. So that's the next break in my graph. So from negative 3 to positive 3, it's all good, but I can't include negative 3 or positive 3. And that's why you see me using the parentheses and not brackets. All right, so to continue, I've picked up my pencil now, and I've come down to the last little chunk, and I can trace until I encounter that hole in the graph. And at this point, I can't trace through that because this point is not actually on my graph. So I know that I have to pick up my pencil and go around that x value. So that x value is at 4. So again, what I know is that everything from 3 to 4 is fine, but we can't include 3 or 4. And then I continue to trace, and I can keep tracing forever. And I don't have to pick up my pencil ever again. So that final boundary, or that final domain, lost a couple of U's there, will be from 4 to infinity. The changes in direction don't affect your domain. And the changes in direction, and by change of direction, I mean we're increasing or going up, and then all of a sudden we turn and we see the graph start to kind of point down. That change of direction that happens here does not affect our domain at all. The only thing that affects our domain is if I have to pick up my pencil to continue tracing the function. So that's domain. End behavior, I know I used the space for end behavior. End end behavior is written the same way every time. It's like a template that you're filling in. Okay? And it always starts out like this. As x approaches negative infinity, y approaches, and then we're going to fill in the box. As x approaches positive infinity, y approaches, and we're going to fill in the blank. What I do for the end behavior is I directly connect that back to any slant or horizontal asymptotes. So literally, whatever I've written right here is what's going to fill in my blanks. So if I write 0 there, I'm going to put 0 in the blanks. If I write 2 there, I'm going to put 2 in the blanks. If I write x minus 2, that's what's going to go in the blanks.
I have a question.
Yes.
So in the end behavior, it's only those two statements? Like, you wouldn't make a statement for, like, for number 6, you wouldn't make a statement for, like, that middle line?
Nope. Because remember, end behavior is only focused on the extreme ends of the graph. So it's really just focused on what happens when we get really far away from 0, both on the right side of the graph and on the left side of the graph. When we talk about end behavior, this middle section is completely irrelevant. It doesn't matter. End behavior is literally just defining what happens at the ends of the graph. That's it. I'm looking through the questions here. I did not have an answer key for this one, Matt. You said, yeah, no. I mean, if I don't actually give you a way to find out exactly what those values are and you're guesstimating, yeah, I'm not going to take off points for that. So if you had put y equal, or your y-intercept is 0.25, that's fine. Yeah, same thing with your x-intercept. Not a big deal. As long as you're close. As long as you're not putting like, go ahead.
Yeah, it was kind of weird because the line kind of stayed on the x-axis for a little bit, so it was hard to tell, like, you know, where the center of it.
Yeah, I mean, as long as you're not putting that the y-intercept is positive 10, we're good. Right? Don't be like way off base and you'll be fine. Good. So what other questions do you guys